Hello, good day, good morning, good afternoon, good evening. I want to quickly solve this question based on request. So the question states that a regular octagon has size of length 10 centimeters. If k is equal to 1 plus root 2, show that a. The perpendicular distance between two of its opposite sides is 10 centimeters, 10k centimeters, and its area is 200k centimeters squared. Okay, before I go ahead with this solution, I would like to quickly sketch this using an awesome application. So here in this application or software, I want to sketch a regular polygon. So I'm not really concerned about the length. I don't want the length to be 10 centimeters. I'm just going to give it an arbitrary length. This is just going to help me explain the proof to the solution to that question. So this is the vertices 8. So that will produce an 8-sided regular polygon, which is what you can see on my screen. So here's the polygon. Alright, so next, let's go back to the question. It says it has length 10 centimeters. So meaning that this length is 10, here is 10, 10, 10, 10, 10, all through. Now, if k is 1 plus root 2, let's bear that in mind. So, okay, let me start with the solution. So I'll say, so here's a proof to this question. I start by saying, given that we are given that k is equal to 1 plus the square root of 2. Alright, so by given that, so we'll come back to that later. Now, our interest is to show that the perpendicular distance between two of its opposite sides is 10k. That is our destination. So here is a side of the polygon FE, and here is another side. Here is the opposite side to FE, which is side AB. Alright, so our interest is to get the perpendicular distance. To show that the perpendicular distance between AB is actually 10k. So first of all, let's introduce some diagonals to this octagon. So I'm going to draw a ray. Let me draw a ray from vertex F to vertex B, or through vertex B, from vertex E through vertex A. So what I need now is to introduce a line. So introduce a line from side FB to side AB, such that that line is going to be a perpendicular bisector of FE. So let me get a perpendicular bisector. Let's see how to get the bisector of FE. Okay, that is perfect. So this is the bisector of FE. So I'm sure that this line is a perpendicular bisector of FE. It forms 90 degrees. And now, since this is a regular octagon, and it is known that the sum of angles in any n-sided convex polygon is given by n, so here just an aside, n minus 2 into 180 degrees. So this is the formula to calculate the sum of interior angles in any n-sided convex polygon, where the n here is 8. There are 8 sides. So when you compute this, when you do this arithmetic, the sum should be equal to 1080. When you sum up all the angles in this regular polygon, it should be equal to 1080. And since this polygon is regular, it means each interior angle of this polygon can be obtained by simply dividing 1080 by 8. And when you do that simple arithmetic, your answer should be 135 degrees. So each interior angle of this uh, uh, regular polygon is 135 degrees. Now if that is 135 degrees, let's look at the triangle FEN. So triangle FEN is a triangle, is an isosceles triangle with angles. The angles in this excuse me, let me show you something. So this angle over here should be, the whole of this angle at F should be 135 degrees, 135, and also the whole of the angle at E is 135 degrees. So my interest now is to check for the angle at the angle NFE, this particular angle over here, and the angle NEF, which is this angle. And let me sketch the isosceles triangle in my working pad. So here is the isosceles triangle. Excuse me. Alright, so this is the isosceles triangle. It looks something like this, and like this. So here's a sketch of the isosceles triangle, so that this angle over here will be half of 135 degrees, and that should be 67.5 degrees. This angle over here is also 67.5 degrees. And don't forget there's a straight line that comes from EF all through AB and stops here. So this from this line would agree with me that that line is a perpendicular bisector of FE. So therefore this angle should be 90 degrees. So it's perpendicular. The vertical line is perpendicular to FE. So this is the diagram again. FE, this vertical line here is perpendicular to FE, meaning it intersects with FE at 90 degrees. Okay, now having seen that, when I introduce another ray, let's introduce another ray. So for clarification's sake, from H through D, you would agree with me that this ray, this particular line, the ray from F through D and the ray from H through D will also intersect at 90 degrees. They intersect at 90 degrees. Let me confirm that point by locating the point of intersection. So the point of intersection there is M. All right, M, not N. And let's confirm the angle between this ray and this ray. That is 270 degrees. But if I go the other way, let's see this way. Okay, so just because my app is saying it, there are no continuation and stoppage from this line. So if I want to achieve my objective by showing 90 degrees, I have to introduce a line segment from that point, from F to M and from M to D. So on that line segment now, I can actually show that this is 90 degrees. Can you see that? So that is 90 degrees. So you can see that this is right angle. Now if that is right angle, the ray from F through D and the ray from H through D is right angle, then you would agree with me that the ray from E through A rather, bisects this right angle, divide 90 degrees into two equal parts. So this is 45 degrees, the other angle here is 45 degrees. And also this perpendicular bisector of FE will also bisect the 45 degrees. Therefore this interior angle at N, so here is N, this interior angle at whatever point it is here should be 22.5 degrees. That is half of 45 degrees. So let's see, and we never need that since we know 67.5 degrees already. It is given in the question that length FE is 10 centimeters, and of course we said this ray here is a perpendicular bisector of FE, which means that it's going to divide FE into equal halves. So this is 5 centimeters, so this is also 5 centimeters. All right, so I think I have enough information to solve for this length. Our zero point, let's call this M, let's call this F, and let's call this say N. So I can solve for length M, NM. I have the sufficient information to solve for length NN. Okay, that is a right angle triangle. Now, so we are given that K is this. So from the right angle triangle, from the right angle triangle FMN, it is obvious that we can actually apply sqrt using tan 67 degrees, 67.5 degrees would be equal to the opposite, which is line NM, the opposite line MN over the adjacent, which is 5 centimeters. So that line NM will be equal to 5 times tan 67.5. All right, so here is 67.5, and when you punch your calculator, the value of tan 67.5 in short form is simply 1 plus root k. That's the value of tan 67.5, 1 plus root k. And this distance NN, let's go back to our diagram. Distance NM is half of the perpendicular distance between two sides of the octagon. So since that is half of it, then therefore the distance, therefore the perpendicular distance between two opposite sides, is 2 times 5 times 1 plus root 2, okay, which is equal to 10 times k centimeters, since k is equal to 1 plus root 2. So the first part of this question is proved already, and I hope this solution was clear enough. Alright, now looking at the second part of the question, it says also show that its area is 200 k centimeters squared. Let's get back to our diagram again. Now when you observe this regular octagon, you see that we have an isosceles triangle FEM, which also produces two right angle triangles. There is also an isosceles triangle in this region. Let me get my ray. G through C. There's also an isosceles triangle FGM. There's also another isosceles triangle GHM. There's another one HAM, ABM, BCM, CDM, and so on and so forth. And in each of these isosceles triangles, we can produce two right angle triangles. So all we need to do is to count how many isosceles triangles are there. 1, 2, 3, 4, 5, 6, 7. There are 8 isosceles triangles, which we can also produce two right angle triangles from each of these triangles, meaning we have 16 right angle triangles in all. So that means I can actually calculate the area of this right angle triangle, then multiply the answer by 16. So to solve the second part, it means that the area of the whole regular octagon, will be equal to 16. There are 16 right angle triangles times the area of one of the right angle triangles using the formula half base times height, where the base is 5 centimeters and the height is 5 times 1 plus root 2, and 1 plus root 2 of course is given as k, so this is just 5 times k. So let's substitute each of these values the in the formula for the area. So that's going to be equal to 16. So here is equal to, the area is now equal to 16 times 1 over 2 times the base, which is 5, times the height, which is also 5k. So 2 can of course cancel 16, can go in 16 8 times. So we therefore have 8 times 5 times 5k, which is equal to 200k, and that solves the question. 200k centimeters square. So here's the end of the proof and the end of the solution. So thank you very much, and I would like you to encourage you to like this channel and leave your comments in case you have further questions. Thank you for watching. Keep keep throwing your questions, and subscribe just to get more insights into mathematics. You have a wonderful